Dear students, in the previous class, we have discussed how to construct a confidence interval for a population proportion. Now we discuss how to perform a hypothesis test for a population proportion. Actually, it is a special case of the one sample Z test for population mean. It is a special case of one sample Z test for testing the significance of a population mean. Now, let us see how to perform hypothesis test for one population proportion. As we have discussed earlier, for a large sample size, the standardized version of p hat is Z is equal to p hat minus p for a large sample size. For n sufficiently large, the standardized version of p hat is p hat minus p root of p into 1 minus p by n, root of p into 1 minus p by n. This is the standard or standardized version of p hat. Now, for the null hypothesis that p is equal to p0, for the null hypothesis that population proportion is equal to p0, this Z becomes p hat minus p0 by root of p0 into 1 minus p0 by n. For the null hypothesis, p is equal to p0. So, Z is equal to p hat minus p0 by root of p0 into 1 minus p0 by n. So, this quantity serves as the test statistics. For testing the significance of one population proportion, the test statistics is given as p hat minus p0 by root of p0 into 1 minus p0 by n. We say the testing procedure as one sample Z test for a population proportion, or simply Z test for population proportion. Z test for population proportion. Now let us see what are the steps. It is based on, this testing procedure is based on two assumptions. One is simple random sample. The second one is n into p0, p0 into 1 minus, n into p0 and n into 1 minus p0 should be 5 or greater than 5. N into p0 and n into 1 minus p0 should be 5 or greater. That is an assumption used for testing the significance of one proportion. Then, given that this condition is satisfied, the first step is formulate H0, P is equal to P0, H1, P is not equal to P0, P is less than P0, P is greater than P0. Two-tailed test, left-tailed test, right-tailed test. So we formulate H0 and H1, null and alternative hypothesis. The next step is determine the value of alpha at 0.05 or 5% or any other significance level. Then compute the value of the test statistics Z as equal to P hat minus P0 by root of P0 into 1 minus P0 by E. Compute the value of the test statistics. Now the critical values are minus Z alpha by 2 to Z alpha by 2 minus Z alpha and Z alpha, the critical regions. So we have these test statistics, then we compute Z, then we compare the value of the Z obtained from the sample with the critical Z values. If the value of Z obtained from the sample is in the critical region, reject H0, otherwise do not reject H0. This is the procedure for testing significance of one population proportion. Now let us consider an example to clarify the points. Now in the example we have an example. An important issue in US is gun control. A survey of 1,250 US adults, 650 favored ban on using or keeping gun. 650 at 5% level, at 5% significance level, do the data provide sufficient evidence to conclude that majority of the adults favor ban on private keeping of guns? Now our H0, P0 is equal to 0.5, tested against H1, P0 is greater than 0.5. We have to test whether majority favors gun control or gun ban. Now N is 1,250, P0 is 0.5, N into P0 and N into 1 minus P0, 625, both are greater than 5. Now 650 by 1,250 is 0.52. So Z is 0.52 minus 0.5 divided by root of 0.5 into 1 minus 0.5 divided by 1,250. The value is 1.41, or the p value is 0.0793. So value of Z, and what is the critical value? The critical value is, that is the critical Z alpha is 1.645. It is a right-tailed test. So 1.645%. The value obtained from the sample is 1.41. So we do not reject H0. We cannot say that majority favors ban on private possession of guns. Sample evidence is not conclusive. Sample evidence is not in favor of suggesting that majority is in favor of banning private ownership of bands. And the p-value is 0.07. But remember this, if you fix the significance level at 10%, then H0 will be rejected. So the choice of alpha significance level is important at 1%, 5%, 10%. Or you simply report the p-value, let the reader decide whether to reject H0 at 1%, at 5% or at 10%. And this is the procedure to test the significance of one population proportion.